Hello. So in this second video, now that we've managed our roughing process, we're going to take a look at our first finishing operation. And specifically, we're going to be looking at a 4D surfacing operation. Since this is a relatively abstractly shaped part that we're working on here, while we could go with a standard rotary finishing operation, it doesn't quite give us the level of flexibility needed to maintain the smoothness of surface that we're after. And ideally, we want something that corresponds to the actual curvature of the part as opposed to just a straight rotary interpolation. And so let's take a look at this now. So under add operation, under 4D rotary, let's take a look at 4D surfacing. And obviously the tool that we've got at the moment, as you can see from all of the tool marks from the roughing here, is a bit on the big side. So let's change that over now. And we're going to take a look at this 2mm spherical mill that's defined. And we can see here it's got a nice taper to it and everything, which serves our needs well. And we need to define a couple of parameters for this operation. The first of which being, under job assignment, we want to define the first and then second curve and the machining surfaces. So starting with the curves, I'm going to grab the first curve, which we're going to go with the top of this vein here, and we'll set that as our first. And then for the second, we're going to go for the top of the next vein. So we're covering this entire surface in between them. Okay. So I'm going to set that now. And then finally, we're going to grab the surfaces like so. Let's get that last surface there. And we're going to define those as machining surfaces. Now, obviously that gives us 1/4 of this part quite readily selected and done. We can either select and grab each individual part, or we can go back into transformations as we have done in previous videos. So that's probably going to be our method. However, for now, I'd like to finish defining this. So we'll take a look at the strategy tab now. And we've got a few options for the approach strategy. And parallel to vertical doesn't really match our needs. It's not quite the best direction for it. We've got some options here. So we can either go parallel to horizontal, parallel to vertical, parallel to 3D plane. Again, doesn't really suit this particular form very well. So I'm actually going to go for morph between two curves. And that is going to maintain the actual form of this curvature, but it's going to blend between the two. However, since these curves are functionally rotations of each other with a slight offset, it means that it's going to maintain that same shape of sweep between each pass. So I'm going to click on Generate Toolpath now, and we'll be able to see, here we are, that same sweep gets repeated pretty much throughout. There's a little bit of modification as it reaches the end of these two curved surfaces. But generally, as I say, it stays pretty uniform throughout, which serves our needs rather nicely. So let's take a quick look at how this comes up in simulation, shall we? So we'll click on simulation now, and we are going to reset, and we're going to simulate up to current operation. Sorry, I managed to completely forget what I was doing there for a second. And we are going to run this, although a little bit slower than it was originally. And as we can see, that this follows the helix of the part perfectly, which again gives us the best possible surface finish relative to the direction of motion in the part, and it's very much what we need this to do. So let's accelerate this a little bit, make sure it serves our purposes throughout the entire thing. We can watch it swing back and forth quite nicely there. Just going to speed past this a little bit. But as we can see, there's no nasty surprises. There's not even any particularly large bits that haven't been neatly machined away. So let's have a quick look at verify compare. And as we can see, Yeah, there's a tiny bit of light blue in there, but given that light blue is 10 microns difference, the obvious answer really would be to use a smaller tool or a tighter step over. But for the sake of this demonstration, I think it covers the purpose quite nicely. So I'm going to pull out the verify compare. We're going to go back into machining, and I'm just going to snap the camera around again so it's a little bit neater. And we are going to take a look at copying this all the way around the part. So we're going to go to the Transformations tab. We're going to multiply the toolpath in the A-axis with a multiply step of 90, since that's degrees at this point, and a multiply count of 4. So now that we've done this, you can see you've got these ghost toolpaths forming that cover the entire part. I'm now going to generate the toolpath of the entire part, and we can see that it wraps all the way around. So for the sake of expedience, I won't bother simulating all of this because it's genuinely just going to be more of the same. But we now have 4 iterations of that same toolpath that we've just checked and proven to be good. So I'm going to see you in the next video where we deal with the final bit of finishing work on this by cleaning up the tips of the vanes on this part. I'll catch you then.